Okay, let me show you around the Tinius-Olsen Universal Testing Machine. The antique Tinius-Olsen Universal Testing Machine. I call it antique because it's not computer controlled. So we've got a hydraulic piston under there. You can't see it, it's behind the panel there. The hydraulic piston, this is hydraulically operated. You see the hydraulic lines in here. This is the loading deck. The loading deck right here. If you look closely, you can see the concentric circles. That's called the bullseye. If I wanted to test a specimen in compression, I'd put the specimen on the bullseye. The loading deck moves up during the test. This is the crosshead right here. The crosshead, the specimen that I'll be testing this evening is right here. What looks like a steel bar. This is the top of the frame. So the specimen is held in. The specimen is held in at the bottom, held in at the top. These are loading clamps. I use those to tighten the specimen in place. The crosshead is controlled by an electric motor, so although it's hydraulically operated, it's a hydraulically operated machine in that there's hydraulic pressure that causes the loading deck and the top of the frame to move up during the experiment. The crossheads remain stationary. However, when I'm loading the specimen, I might want to move the crosshead up or down. So here's the electric motor that controls the crosshead. I don't know if you can read this. So the crosshead is controlled by these buttons. These buttons, raise and lower. I don't anticipate having to use those tonight. So before I start the test, I have to do something called floating the table, which means move the loading deck up a little bit. See this wooden block? That's stuck under there. So I'll know that the table is properly floated when I can pull out that wooden block. So in summary, we've got the hydraulic piston down below, the loading deck, the crosshead, the specimen, and the top of the frame. And in the back you can see my GoPro camera. I'm going to be filming the specimen during this experiment. I'll be filming it from the back side though. I see a safety vest back there, maybe I should put that on. Okay, now how do I know how much load I'm applying to the specimen? Okay, you see the loading gauge here? Let me step back so you can see this in context. Okay. To add load to the specimen, I'm going to turn the loading wheel. This opens up a valve that will allow hydraulic fluid to flow through these hoses into the piston that's down below the loading deck. So I've got a loading wheel. It opens a valve that lets the hydraulic fluid in. And when I want to release load, I turn the unload wheel. To release the load, I turn the unload wheel. That opens up a valve that lets the hydraulic fluid back out again. I already told you about the raise and lower buttons for the crosshead. Raise, lower. Start and stop. The start means I'll turn on the hydraulic pump. The stop means turn off the hydraulic pump. Do not operate this equipment without authorization. I am the authorization. Okay, so what was I telling you about? The loading gauge. So we'll look very closely here. Starting at 0. Where is it? 0. So 0 is 0 is 0. You see these three numbers here, 250, 2,500, 10,000. This machine actually has 3 different settings. We've got a low range 250, middle range 2,500, high range 10,000. So as I follow this loading gauge around, okay, I see 1,000, 10,000, 40,000. At the 12 o'clock position, 1,500, 15,000, 60,000. Okay, what does it look like the capacity is on this thing? Capacity, well, if we're on the low range setting, 3,000, middle range 30,000, an absolute maximum 120,000. So 3 different settings on this. Okay, so here's how we select the proper loading range. See load cell, low, middle, or high. In a little while here, when I turn on the machine, I'll turn this knob, and you can see how the numbers in these little windows will change depending on which range I select. So right there, that's the knob I turn to select which setting I want, whether it be the low range, the middle range, or the high range. And then over on this side, okay, this is behind the strain indicator box. If I can move this out a little bit. Okay, where am I? Behind the strain indicator box. Okay, in context. Okay, zero adjusters. That's if the load is a little bit off in terms of the datum. So I'm going to start off with 0 pounds. I fine tune it using these knobs. Zero adjusters, low, middle, or high range. I'll turn the machine on in just a minute here. The on-off lever is on the side. So since I'm standing here anyway, let me turn this on. Okay, now what happens when I turn it on? We got some lights here in context. When was this last calibrated? Can you read this? December 2, 1999? Long time ago. Okay, so right now I'm on the middle range. So 30,000, that must be the maximum. 30,000. Watch what happens when I turn this knob over here. So that's middle. What happens if I go to low? Okay, what happened here? We got green lights. 3,000 is the maximum. See, 3,000 maximum. Okay, what happens when I go to high range? Sorry, I'm trying to work the camera and adjust this at the same time. Okay, so now it says 120,000 is the maximum, which is consistent with what it says on the gauge here. But we're not going to do that today. We want to work with the middle range. Okay, so right there. So everything turned on. So we've got 2 strain gauges on the front. I'm not sure you can see this. I can barely see them under all the glue here. It looks like I've got one that's horizontal and one that's vertical. So 2 strain gauges here. And then around the back side, there's actually 2 more. Let's go walking around the back side to look for the other 2. I think, oops, let me move this chain out of the way. It looks like there's 2 more back here. What is this, number 3 and 4? So 2 strain gauges on the front, 2 on the back. Around the front again. And while I'm standing here, this is what the back of the loading dial looks like. And you can see my reflection there. See all this circuitry? This place is like a museum. So the back side of the antique Tinius-Olsen universal testing machine. Okay, let's walk around to the other side. An electrical outlet here if you need it. And some unrelated bolts, unrelated stuff laying here. Okay, how are we going to measure the strain on this thing? Okay, so the wires are coming out of the strain gauges. Okay, follow the wire down. Okay, let's go to the back of this first box. Switching and balancing unit. Switching and balancing unit. Okay, so if we look in the back here, see how it's plugged in? I don't expect you to rewire this, but just to give you a general idea of what's going on back here. Okay, I don't want to stick my camera back there. So we've got a switching and balancing unit. In the previous lab activity, we didn't need a switching and balancing unit because we weren't measuring 2 different unequal strains. Because we've got 2 strains that are not equal to each other, we've got a longitudinal strain and we've got a transverse strain. Because of that, we need a switching and balancing unit. We're actually going to be operating on 2 different channels. So here's the channel selector, like one of those vintage television sets where you switch the channel using a knob. We're going to be using 2 channels, channel 1 and 2. So I'll turn this knob to select the appropriate channel. Okay, we got the wires coming. My finger in the way. We've got the wires that come out the front of the switching and balancing unit. Okay, I'm going to plug these into the strain indicator box which you've seen before. Okay, so let me plug these in. See, the colors match. The colors match white, black, green, and red. white, black, green, and red. Let me shut this off while I plug them in. I can't do two things at once. I might drop my phone here. Okay, and I plugged everything in. How does that look? Matching the colors. So we're going to be using a 4-arm Wheatstone bridge. The Wheatstone bridge is built right here into the B.L.H strain indicator box. This is just a calibration knob. Right here, the strain indicator window, the balancing meter, gauge factor, that is determined by the strain gauge manufacturer. Battery check, if I flip that, you see the needle jump. This thing could be operated by batteries, and I could flip that switch to see if there's life, but today we're going to be plugging it in. So I plugged it into an extension cord down here on the floor. So I think I've explained everything that we need to know for today's lab activity. You know how I balanced a Wheatstone bridge? Remember that when the specimen is subjected to strain, it's going to deform a little bit, and so that messes up the Wheatstone bridge. Therefore, the little black needle isn't going to be in the middle anymore. How do I get it back in the middle? Strain measurement wheel on the side. So in a previous video, I gave you the gist of how this box works. So if I think of anything else, I'll mention it later. If I think of anything else with regards to this machining. So let me put everything in context. The piece of paper sitting on the loading deck is the checklist. Alright, so that is a tour of our antique Tinius-Olsen universal testing machine. So now I'm going to do the actual lab activity.